real goal is like to share how we have set up our monitoring, how we use it, and definitely happy to see, especially because like there's a lot of analysis that has been done and like a lot of data that could be available. So see how like these logs could help you down the line and just to inform how this is going. So yeah, I'm a research engineer at Cloudflare. I work on the various distributed web projects, IPFS, Ethereum. Also participate in like all the standards like DNS, and I like croissants. So I know we're in Portugal and like it's mostly pastel de nata. They also have very weird brioche croissant, which I'm not trying to qualify it as croissant, but yeah, that's the case. So we'll see if there are some available later today. Today the presentation, so I'm going to present quickly an overview of like Cloudflare system, what it means, then what is Cloudflare monitoring and the various systems we're using, and then where to go next, things we have in the pipeline for like improvement for this. So yeah, first Cloudflare architecture. So most of you in the room, I think, know what like a gateway is. It's an HTTP interface to the IPFS network. The main URL for Cloudflare gateway is cloudflareipfs.com. Even though we also do provide the capability for people to have like X509 certificate on their own domain, and so they can serve whatever CID they want. As mentioned before, the gateway is closely tied with like standard HTTP cache, which sits close to like end users, and so that allows us to like leverage standard web infrastructure to serve IPFS content. To retrieve IPFS content, we need at some point to have some IPFS nodes, mostly because like IPFS nodes are accessible at the moment mostly through TCP, even though there are like some new transport which are being developed. And these nodes are also caching long-lived content, so that if you have the popular content that is accessed from multiple locations, when Cloudflare nodes need to access it, we just make less requests to the IPFS network. So yeah, overall, that's the architecture that we have. In terms of data generation, it's not limited to that, but these are the main systems that we're using. So we have a monitor that is just checking the health of our gateway via various active probes. And then we have more like data that like is sent by the gateway. So we have like Prometheus data. We have Sentry, which like allows to like debug the code that like is being run. And then finally we have like ClickHouse, which is a column-based database for like data with high cardinality. What I didn't mention is like we're not using raw Kubo nodes. We're using like Kubo as a library, which I think is like kind of a plan of having libIPFS at some point. But like it's kind of like half in-house, half open source implementation for this. What is kind of tricky that we've seen operating like an HTTP gateway is for IPFS, the kind of like base layers, you have a CID and you look at which CID is being requested, how it is accessed, like you have bit swap, you have like the content routing. For HTTP, you had like one layer on top, and like the main layer we see is like the naming. So like you can have like a raw domain, so like IPFS or Cloudflare.com, which would access the content, but then you might want to have like, I don't know, a cache on top, and then you have like another customer on top, and then you have like another CNAMEs. And so being able to have a view through like all these different steps is kind of tricky, and so that's why, yeah, trying to figure out what to make sense of this mess leads to a lot of like debugging and headaches. So to dive a bit more in these systems, what actually is Cloudflare monitoring? And so like these various systems that I've mentioned before, and some of you also mentioned in like previous presentations. So first of all, we have Prometheus, which is very useful. Like it's a time database working on like low cardinality. When there's like high cardinality, it just explodes. So we have like limited number of metrics per cardinality, but it's very good for like live monitoring. So like for instance, if you want like the number of like response that you have like on your backend, or like if you want to know like I think Leo mentioned about like is it like from a gateway or not gateway, like very small flippers. Prometheus is very good for that. It's also connected to our internal alerting systems based on like various threshold rates. So you have like just simple mathematical functions and operation that you can apply on top of the data. Another system that we're using is Sentry. And so Sentry is like different than Prometheus. In a way, it's not that much of a database, but it's more like an event-based, and like focused on like the errors that our system could be producing. So the good thing is like it provides context about the errors that we see. So for instance, like you have the host name, you have the URL that has been accessed, and like custom tagging that you can have on the error. And so you would see exactly which part of like the code, as well as like the stack that was used to generate this event, which is very useful when you try to reproduce things that the customers have been experiencing. And finally, we have ClickHouse. So ClickHouse is just Cloudflare way to have a lot of data with like arbitrary data with like high cardinality. So it's a column-based database. Cloudflare also samples the logs and like data that like we go to ClickHouse so that we just don't store everything that happens. We can store some aggregates. And it's far more useful for long term. So like, I don't know, you have like a lot of like CIDs and root CID that could be accessed, and you can make normal SQL queries over that data. Finally, something we've open sourced earlier this year is the IPFS monitor. So it's like a black box monitoring tool for the IPFS gateway. Can test on like multiple scenarios, so like update of the DNS link, caches, new content created on like various spinning service. And it also provides Prometheus exports so that we can like have alerts when something is going bad. The data result that we had earlier this year, so I think it's like March, where you can see that for newly created content, sometimes it's very fast, like 200 milliseconds, and I would not say it's very fast, like it's okay. But most of the time, it will be very slow. And so definitely that's something that I will mention later on in terms of like the improvement that we want, especially the main pain at the moment is like through the content routing. When the content is in cache, it's just fast. Like, I don't know, the maximum is like half a second, which is good. And when the CID isn't available, that's really depending on like the node and the strategy. So we've tuned it a bit since then, but mostly it just takes time to figure a CID is not there, which is not that good because you have like this loading screen just waiting for nothing. From that, where do we go next? So this is a non-exhaustive list of like improvements that we would like to have, but mainly having some like kind of like peer rating and like peer reputation would be interesting, especially to know which peer the gateway should peer with, depending on like the content. Also, like on content routing and content providing, having like gateway plus indexes plus some more like interactive participation with like data provider is like important because like, I don't know, like a minute to like retrieve a content is just too much on certain providers. Then having like some standard around like gateway names and resolution is, I feel, also important. And that's mainly, I think, going through like the IPNS land. We're not seeing that much usage for IPNS, but definitely that's, compared to its usage, there's a lot of requests coming in terms of like how to tune and how to define. So there's been a new IP coming in to define IPNS, but yeah, definitely more involvement through here could be interesting. One data that like we are interested in more generally is like a content delivery network, is like how efficient is the content layout that is being delivered to IPFS? Are people actually building DAGs that are efficient for caching, or is it just like using the like normal Kubo like DAG building and that's it? I know like some projects like have been using efficient content layout, should be like for Docker, NPM, or like some videos that we've seen, but overall it's kind of like an unexplored area that could be interesting to reduce the amount of storage. Similar, one thing that is coming and like definitely more for like one additional source is like distributed tracing. So on a similar note to Sentry, like distributed tracing would allow to just better understand through like the whole pipeline and various systems that we have where actually is something taking time. So if we see the time for discovering content is just too long, that maybe like help us prioritize the things that like we want to have and want to see. And finally, integration with enterprise tool. It's more like a gateway thing. Like generally, I feel there's been especially the way like the various packages and like IPFS nodes have been built, it's sometimes tricky to like integrate one new tool without just rebuilding the thing. So yeah, that's more general comment. Otherwise, thank you. There's definitely been like a lot of like, I think, interesting like measurements and things. And now is the time for like ask the gateway anything that you have seen or have not seen in the slide. Definitely happy to answer.